In this lesson, we're going to be talking about slope. We're going to define it, we're going to give some visuals of what it looks like, we're going to have some coordinates and see if we can figure out what the slope is between the coordinates, and we're going to be given a slope and see if we can come up with some coordinates that create that slope. So here's what we got. So the idea of slope is typically we use the letter M that represents slope. And slope, if you've talked about a visual with it, it is the rise over the run. So when we go from one coordinate to another on a graph, we talk about what is the rise in relation to what is the run. Another description of it is change in your y's divided by change in your x's. You may have also seen it as y2 minus y1 divided by x2 minus x1. It also is a rate, or a rate of change. So if it's in relation to a word problem, it may be miles per hour or feet per second, and that would be your rate, which would also be your slope. So a couple different descriptions that we can have for slope is we have a positive slope. So visually, we have a coordinate going to another coordinate, and when you connect the dots, you have your line that looks like that. So if we were to describe what the slope is, and if we wanted to compare it for change in y with relation to change in x, so we would go from this coordinate to this coordinate, we would go rise over run, so it would be a positive over a positive, and a positive divided by a positive is a positive. If we so happen to go the other direction, which is fine, we would just go in this direction and then this. So we would go down for a rise, which would be a negative, and then we would go back, which would be a negative. So our m would be a negative divided by a negative, which is also going to be a positive. So regardless of how we look at it, we're going to create a positive slope. Then we have a negative slope. So if a positive is a line going up, a negative is going to be a line going down. And if we start to compare the rise over run or the change in y, change in x, here we would go down and to the right. So that would be going down, as our change in our y values would be going in a negative direction, but our x's would be increasing. So our slope would be negative over a positive, which would simplify to a negative. If you went the other direction, go from this coordinate to this coordinate, we would go up, but we would go left. So we would go up, but we would go left. So on that, our slope is going to be a rise, but then it's going to be a negative run, which still turns out to be a negative. So these two visuals, when you graph them, there's an equation related to it, and they have a y equals mx plus b look to them. And that is a slope-intercept form. Now there's two other kinds of looks that can happen, and they're kind of special cases. So one of them is a horizontal line. And we're still going to do exactly the same thing that we did with this. What is the change in the y with relation to the change in the x? So on this, our change in our y is nothing, but our change in our x can be anything. So we'll simplify this and just kind of make it a something, anything other than 0. So that's going to turn out to be 0. All right, so that is a 0 slope. So you can represent it with a word, or you can represent it with a number. All right, and then our other situation is a vertical. Another special case is a vertical. So if we go from point to point, and we're going to describe our change in our y and our change in our x. So our change in our y can be something, anything. So we'll call it a 1, but our change in our x is going to be nothing. So it's going to be a 0. Well, you can't divide by 0, so that is going to be undefined. And that is the slope to it. It is known as undefined. All right, you also may have heard it as a no slope. It means one and the same. All right. Now these have special cases with their equations. They do not look like these two. A horizontal line looks like just a y equals, and it's wherever it hits the y-axis, that ends up being the value. So it's just a y equals, let's call it a 5. Let's say that's a 5. If it was a 4, it'd be y equals 4. If it was a negative 2, it'd be a y equals negative 2. On this one, a vertical, it's also a special case, and it's just an x equals. And x equals whatever, wherever we hit the x-axis. So again, we'll call it a 5. And again, it could be anything as long as it crosses the x-axis. So those are our kind of situations that we're going to be looking at. So we're going to find the slope. We're going to talk about a couple different ways of how we go about doing that. So directions are going to be find the slope, and we're going to be given a couple coordinates. So for the first one, and we'll show you a couple different ways to do it, and then you kind of figure out what do you like, what works for you. Okay, so the first one is, the first method that I'll use is I'll use the formula. The y2 minus y1 over x2 minus x1. So literally you're just plugging in values. So let me talk about what is the y1, the x1. This is the x1 and this is the y1. It's literally just the first x in the first coordinate. And then this is your x2 and y2. It's the second coordinate. So it's the y value from the second coordinate, the y value from the first coordinate. And so we just plug things in and we do the math. So here we would have a 3 minus a negative 1 if we just plug things into the formula. And then we have our negative 3 minus our first x value, which is 3. So a 3 minus a negative 1, I'm going to add the opposite, that becomes a 4. Here I'm going to add the opposite, and that becomes a negative 6. And if we simplify that, it'll be a negative 2/3. So we have a graph that's going to be going down at a rate of 2, and we're going to be going horizontal 3, is what we're looking at on this. So a different way of doing this, which is actually one I kind of prefer, is if I take the exact same coordinates, and I'm going to talk about slope being change in y's divided by change in x's. So I'm really just going to kind of compare. This y value in this coordinate goes from a negative 1 to a positive 3. So that change in that y is up 4. So I'll give it a positive 4. This x value changes from a 3 to a negative 3, which is down 6, and that literally is my slope. So I went up 4. For the y values, we went down 6 for the x values, and then I just simplify my fraction. So I think this is a little bit nicer, it's a little bit cleaner. You're literally just counting. So let's do another one. So we'll have to make it a little more difficult. So we'll have a 1/3 and 3/7 and negative 1/2, 13/14. So exact same thing. I prefer this one, so I'm going to try and figure out what are my change in my y's and my change in my x's. The problem is, for me to count and figure this out, I need common denominators because of the fractions. So let me take care of that. So between my first one, my x's, because I'm going to be looking at my change in my x's, so between those two I can make them both sixths. So and then between the 7 and the 4 I can make them both 14s. Alright, so in order to get from that 3 to the 6, I'm going to multiply by 2, multiply by 2, multiply by 3, multiply by 3. So I'm trying to make equivalent fractions. I don't have to do anything to that one. So my values are going to be 2 over 6, 6/14, and then a negative 3/6, and I didn't do anything with that. Okay, so now I'm looking at what am I changing my y's. Changing my y's, changing my x's, and let's see what we got. So we went from a 2/6 to a negative 3/6, and that is going to, sorry, y values. We went from a 6/14 to a 13/14, so the change in my y values were up 7/14, and then my x values, I went from a 2 to a negative 3, so that's going to be down 5. So down 5/6. So not a nice answer, so I need to manipulate it a little bit. So we have a 7/14 divided by negative 5/6, which then I can do multiply by the reciprocal, so negative 6/5, and then I can simplify my fraction. So if I simplify, I have the 6th can simplify, actually even better, the 7 and the 14 can simplify, that becomes a 1 and a 2. The 6 can simplify with the 2 and makes it a 1, makes that a negative 3. So my final slope is going to be a negative 3/5. So even though I have ugly numbers, doesn't change the process. I just have to figure out what my common denominator is first. All right, so we're going to do 2 more, and we're going to try to figure out, given a slope, how do we create another coordinate to satisfy that slope. So, all right, so we're going to be using the same point for both problems here. We're going to be given this coordinate of 4, negative 5, and we are going to create another coordinate and that other coordinate is going to have specific slopes. That has a slope of whatever the situation is. So for the first one, we're going to be looking for a point of, or a slope of 5/2. Now we're given a coordinate of 5, or 4, negative 5, and we're trying to find another coordinate that has a slope of 5/2. So you can do the formula and you can kind of plug in what you know, plug in what you don't know, or even better, if you did the change in the y and the change in the x, you can pull it straight from what you got here. So this is your change in your y values. So your y values should change by 5. Well, and it's a positive 5, so we're going to go up 5. Gives us a 0. And then this, we need to change in our x's to be 2. So that's going to give us a 6. And that's it. That's our coordinate. Now if we went another 5 and another 2, that'd be another coordinate. And so we can continue this pattern on and on and on and forever, and that will always simplify back down to the exact same slope that we got. So kind of a quick visual, make sure we're good with it. So this is a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, go to 6. So we have a point that's starting at 4, negative 5, 4, negative 5, so roughly there. And if I go up 5 over 2, follow the slope, I have exactly the coordinate 6, 0. So let's do one more. And we're going to have an undefined slope. Okay, so that's it. So what does that mean? Well, again, we're looking for a coordinate, and when we graph it, it has a very specific look to it. So you could do a visual to this, or you can go back to the idea of the slope. So the slope on an undefined is always something over 0. You're dividing by 0. So I'll just make up anything, whatever. Something over 0. So that's my change in my y, that's my change in my x, and I apply my pattern. So my y values. I want my change in my y values to be 3. So then that's going to be a negative 2. I want my change in my x values to equal 0, so my x isn't going to change. That's the key. There are no change in your x's, so they're going to remain constant. So if I graph that and I create a visual to it, then I plot this point, and here's where I start at, and I don't want any change in my x's, well then my x's are going to remain constant. So it could have, in theory, been any of these points along that line. And as long as it's on the line, it would have worked. So that is one of the points on the line. So there's technically an infinite amount of answers to this as long as your x stays at 4. All right, so that was a little bit of a snippet of slope, how to find slope, how to deal with slope, what the visual of it is, and that's it.